Hello everyone, in this video I'll explain the course content number 5, analysis of a stepped bar. This is the example of a stepped bar which I am gonna analyze. On STAAD Pro, create new file, and the first step is to choose grids. So choose beam grid. Now we have to change the view. So select view and change the view to the front view. Then click on snap knot beam and click on the first point and draw beams for the bar. In this example we have 3 steps of the bar, so we have to add 3 beams. Now close snap knot beam. Now click on shift N to show the number of knots. Now go to properties. We have to assign the properties to all members. Choose define, click on rectangle. Now add the values for bar thickness. First is 3 meter. Add. Second is 2.5 meter. Add. Third is 2 meter. Add. Close. And assign the properties to the beams. Click on first and select the beam assigned to the selected beam. Yes. Now choose second property. Click on second beam. Click on assign to selected beam, assign. Similarly, third, click on third property, third beam, assign to selected beam, assign. Yes. After assigning the properties, click and check the 3D rendering view of the stepped bar. Close. Now next step is supports. Go to supports. Choose create. Choose fixed, add. Select support 2. Click on use cursor to assign, select knot. Assign to selected knot, assign. Yes. The support is now assigned to the end of the stepped bar. Now next step is loading. Click on load case detail. Add. First add dead load and name it as DL. Click on add. Now choose live load. Name as LL. Add. Close. Now click on dead load. Add. Assign the self load. Add. Close. Click on live load. Add. Click on nodal load. Node. Add minus 200 kilonewton. We are using minus sign because the load is acting opposite in the direction of the bar. Add. Now add 100 kilonewton and add, and now click on member load. Uniform force. Add minus 150 kilonewton per meter and D2 is equals to 2 meter in GY direction. Add. Close. Now click on self weight. Click assign to view, assign. Yes. The self weight is now assigned to the whole bar. Now click on Fy2 minus 200 kilonewton. Now change the cursor to node cursor. Click on the node 1 and assign the load. Assign to selected node, assign. Yes. In this example, the load is acting on the bar is in the horizontal direction, that is along the bar. So click on the load fy minus 200 and modify the load and change it to the fx minus 200, modify, close. Similarly, change the second one to the fx, click on the load 2, change it to fx 100 kilonewton, add, close. Now assign all the loads to the bar. Click on load 2, click on node 4 and assign to the selected node. Yes, the loads are now assigned in the direction of the bars. Click on the load number 3, uniformly distributed load. Now change the cursor to the beam cursor. Select the beam, assign to the selected beam, assign. Yes. Now the uniform load is assigned to the beam. Change the scale of the uniform load. Click on view loading diagram. Now to view the loads values, click on the labels, select load values, apply, OK. We can see the load values of the bar. Now the last step is analysis. Click on analysis, click on analysis commands, select all, OK. Now click on run analysis, save. Errors are 0, so we can go to the post processing mode. Click on go to post processing mode, done. Click OK. Click to see deflections. So deflections are not visible. We have to change the scale of for the deflection. Click on the labels and click on scales. Change the displacement value to 0.1. Apply. OK. Now the deflection of the bar is visible. Click on the displacement and utilization ratio, and also we can see the forces in x, y, z direction and also movements in x, y, z direction of the bar. Now go to reactions, results, and also we can see the animation of the deflection of the bar. Click on animation, click on deflection, apply, OK. This is the deflection of the bar. Now go to displacements, and the table of the displacement of nodes and beams are shown. You can also see the properties of the beams. So change the node cursor to beam cursor. Double click on the member beam. See the geometry, property, loading, shear bending, deflection. We can also print this data. Click on close. Similarly, we can see same for the other beams. Click on close. That's all for the analysis of a step. Thank you everyone.